Hello friends, I am Mr. S. Sazni from Department of Mechanical Engineering, Sharad Institute of Technology, Polytechnic, and I am teaching the subject Thermal Engineering. So I think that you have gone through all the lectures related with the first chapter, that is Fundamentals of Thermodynamics, and almost all the concepts you might have understood. So in today's lecture, we are going to see the questions asked from this topic in the last three MSBT papers. Along with these questions, we are also going to see what are the expected answers for those questions according to their weightage. So many times students have a doubt regarding how much answer should be written for the given question. So to clear these doubts, in today's lecture we will see what are the questions asked and what are the expected answers for the same, as well as what is the distribution of marks for that question. So we are going to see all these questions today. In my previous lectures, I have already given the questions, but the expected answers for the same were not present. So if you are having doubts related with that part, then that will be cleared in this lecture. So the first question, that is define intensive property and extensive property and give example for each. So this question is from winter 19 paper and it carries 2 marks. So in the slide you can see that the definition for the intensive property is given, that is a property which does not depend upon the mass of the system, and the example for the same are given below, that is pressure, temperature, density, and specific enthalpy, etc. So this part will carry 1 mark. The next part, that is extensive property, the definition for the same is it is defined as the property that depends upon the mass of the system. And similarly, the example for that what is given is total volume, area, enthalpy, entropy, etc. And this part will carry 1 mark. So you just need to remember only one definition that are given in this slide, and along with that one example is necessary. Also, I have earlier told that there are most of the times misunderstanding related or there is confusion. The students exactly write the opposite definitions for the same. So I have also given the hint for remembering this definition. That is for extensive property. You can just remember that the property which is dependent on some external parameter. So extensive, it will depend on some external parameter, that is nothing but mass. So this question will carry 2 marks. Now the second question from the same paper, that is winter 19. However, this question is asked for 4 marks. Explain the concept of flow work associated with flow process. So we have studied the concept of flow work. You can write the definition that we have studied. So even if you start simply with the definition of flow work, that is the force required to push the fluid into or outside the boundaries of a control volume, then also it is okay. It is also necessary that you are since the question is asked for 4 marks, so in such case a diagram is necessary. So with the help of that diagram, if you are providing some information or definition regarding the concept of flow work, then also it is okay. But in this model answer, along with the concept of flow work, they have given the equation for flow process. So this part you have studied in steady flow energy equation. So the diagram that is given here is for is related with the derivation of steady flow energy equation, and you can see there the equation, that is the summation of all types of energy, that is kinetic energy, potential energy, and internal energy, plus addition of heat, and that is equal to again all the addition of several types of energy, that is kinetic energy, potential energy, internal energy, and along with this there is addition of work. So I think that you have studied this in steady flow energy equation. So the left hand side will refer to the inlet conditions and the right hand side is referring for the outlet conditions. If we look at the marking scheme or the distribution of these 4 marks, then the 2 marks are allotted for writing the concept of the flow work, and the remaining, or we can say that 2 marks might be allotted for the definition of the flow work, and the remaining 2 marks might be allotted for the required diagram and for writing the necessary equation related to the flow process. So this much theoretical part, I think it is sufficient for the 4 marks. These were the questions that were asked in the paper, that is winter 19. Now let's see what are the questions from summer 19 paper. So the first question is differentiate between heat and work. So again this question is asked for 2 marks, and if the questions related to the differentiation is asked for 2 marks, then definitely there will be 1 mark allotted for each point. So you can see a table for differentiating between heat and work. So the first parameter, that is definition, is given. So heat is a form of energy that is transferred between the system and surrounding, or two systems, due to temperature difference, whereas work is the amount of energy transferred by work acting through a distance. So you can write out the definitions that we have already studied. The second parameter that is taken is function. So heat is a function of state, whereas work is a function of path. And then again one extra parameter is given, that is energy interaction, that is how heat or work will transfer. Then in case of heat, it will be transferred due to temperature difference, whereas work will be done on the system or by the system based on the magnitude and direction of the applied force. So these points are sufficient. It is very much necessary that you should always remember that if the question is asked for 2 marks, then instead of writing 2 differences, you should better write 3 difference. Or if the same question was asked for 4 marks, then try to write at least 5 points. That is, if you are writing 1 point extra, then even if something goes wrong with some of the difference, then there will be some additional parameter that will help you to get out of out marks for differentiation. So you can also consider this as a hint while writing the question related with the differentiation. Now let's see the next question. State Clausius statement of second of thermodynamics. So as we have already studied the second of thermodynamics, it has 2 statements, that is Kelvin-Planck and Clausius statement. But in this question particularly only Clausius statement is asked, and the question is for 2 marks. So it will be necessary that we are writing the statement for Clausius statement only. And if we see at the mark distribution, then for the statement 1 mark has been allotted, and for the diagram of Clausius statement the 2nd mark is given. So we have seen, we will just repeat the Clausius statement. So it states that it is impossible for a self-acting machine working in a cyclic process without any external force to transfer heat from a body at a lower temperature to a body at higher temperature. Thus mechanical work expenditure is necessary in order to transfer heat from a body at low temperature to a body at high temperature. And the same has been explained with the help of this diagram. So in the diagram we can see that some input energy, that is work, is given to the heat pump, and as a result of this work expenditure, heat is transferred from low temperature reservoir to high temperature reservoir. So in this way the question was asked for 2 marks in the paper summer 19. Next question, state extensive property and intensive property with 2 examples each. Now you can differentiate with the question that is asked here and in winter 19 paper. So the question is same, just the difference is that in winter 19 the same question was asked for 2 marks, but here the question has been asked for 4 marks. So here you can see first the definition is given, that is extensive property, and several examples are given. So here the distribution of marks is necessary to understand. For the definition of extensive property 1 mark is allotted, and if we are writing 2 examples then only another 1 mark will be allotted. So in this way 2 marks are allotted for extensive property, And in a similar way, for definition of intensive property, 1 mark will be allotted, and 1 mark will be allotted for writing the 2 examples. So it is necessary that you should know several examples for both these properties. So this was about extensive and intensive property 4 mark question from the paper summer 19. Now again the next question. So this question is having a great weightage, that is 6 marks. But if we see at the question is explain the application of second law of thermodynamics to refrigerator. Further, they have also asked that state any 3 functions of steam condenser. So this second part, that is 3 functions of steam condenser, this part is actually from another topic. So we will focus only on the first part, that is explain the application of second law of thermodynamics to refrigerator. So if we look at the mark distribution, then 1 mark is allotted for the diagram, and 3 marks are allotted for the explanation of the same. So here again we can see that instead of heat pump, which we have seen in the previous question, here refrigerator is used. R is shown, which is nothing but refrigerator. We are providing some external work to this refrigerator, and then heat will be transferred from low temperature body to a high temperature body. So this is the application of second law of thermodynamics. So if we are drawing on the diagram and explaining, then you will get 4 marks. And since the question is asked for 6 marks, the 4 marks are for the first part, and 2 marks are allotted for the second part. But since the second part we have not studied yet, we will not see that. So this was about 6 marks question related with the application of second law of thermodynamics. Then again, so these were the questions from summer 19. You can see that as compared to winter 19 question, a large weightage has been given to the first chapter itself, contributing about 12 marks. The next questions are from winter 18 paper. So the first question from winter 18 is a definition, that is for flow work and entropy. So this question is asked for 2 marks. So you can see the definition. You have already seen the concept of flow work, so the same will be repeated. But since the question is asked for only 1 mark, it is only necessary that you are writing the definition of the flow work, and you can additionally write the formula for the same. So this will carry 1 mark, and then again for the definition of entropy, 1 mark will be allotted. So the entropy, you can see the definition here, that is entropy is defined as the property used to measure the quantity of energy or irreversibility of a process. So there are many definitions from several books. You can write any definition, and that will give you 1 mark. So this was regarding the definition related with flow work and entropy, carrying 2 marks. Then again the next question was asked, that is define irreversible process and state the factors making the process irreversible. So we have also studied this, what is a reversible and irreversible process. Then again after definition we have seen what are the examples for the same. So here they have just asked the question in different manner. Instead of examples, they have asked what are the factors that makes the process irreversible. So if we look at the definition, then the definition is given here. A process is said to be irreversible if it cannot reach back to its original state without using external work. The spontaneous process will not be a reversible or quasi-static process. So just the main part here is the definition, that is if the process cannot reach back to its original state, then we are calling it as irreversible process. It is important to keep in mind that practically there are no any such kind of a reversible process, because there are several factors which will definitely make the process irreversible, and these factors are given below. So you can see here the irreversibility is classified according to the causes. So they have given three factors. The first one is external. So the external factor, these are the external physical factors such as friction, resistance, viscosity, surface tension, finite temperature difference, etc. So due to all these external physical factors, the process will be irreversible. Then again, the energy lost due to friction can never be regained, because we know that we have studied that energy can neither be created nor be destroyed. Just the thing is that some part of this energy will be converted into some another form, and we cannot utilize some part of that energy. So just as given here, if the energy lost is in the form of friction, then we cannot regain that back. So the direction of the process cannot be reversed without supplying some external work. That is, we have to perform or do some external work, and as a result of this, the process will be irreversible. Then again, the second cause for irreversibility of the process are the internal factors. So the irreversibility caused by properties of working fluid in a process like throttling or free expansion. So when a gas expands, it uses its internal energy to do so. It cannot contract on its own and reverse the process. So again, these internal factors will cause the process to be irreversible. And the last factor, that is the chemical properties. The irreversibility caused by internal chemical properties such as structures and bonds. So due to these chemical properties, the process will again become irreversible. So these are the factors that will make the process irreversible. This question will carry 4 marks, and the weightage are given, that is for definition 2 marks will be allotted, and for writing the factors making the process irreversible 2 marks will be allotted. So this was a 4-mark question from winter 18 paper. Then the next question, again from winter 18 paper. Here they have asked, state steady flow energy equation and apply it to condenser with the block diagram. So you have studied steady flow energy equation. So that equation is very much important in this chapter, because even they ask any devices instead of condenser. So if they are asking boiler or engine, turbine, then for any device, at least you can write what is the steady flow energy equation, and that equation will give you 1 mark. So for that 1 mark, you should know what is this equation, and the same equation you can write commonly for any question related or simply if in the question paper they have asked regarding steady flow energy equation, then even simply if you write that equation, then you will definitely get 1 mark for the same. So here you can see the steady flow energy equation is written. 1 mark is allotted for that equation. Along with this equation, you should also write what are the terms involved in this equation. So the details regarding the each term involved in the equation, 1 mark will be allotted for the same. Then regarding the application, so they have asked steady flow energy equation for the steam condenser. So here simply you should do one thing. You should draw the diagram even if it is not asked, because the question is for 4 marks. So every time you should remember that whenever a question is asked for 4 marks, then first you should try to draw the diagram if it is applicable. So the diagram will give you 1 mark, and if you are applying the steady flow energy equation to this device, that is condenser, then you should know that here the heat will be lost, and thus we should take heat as negative. So we should put that parameters in the given equation, and also the datum and all those things you have already studied, what are the values which are to be substituted as 0. Then after substituting those values, the final equation you will be getting, that is nothing but Q is equal to H1 minus H2. That is whatever the heat will be lost, it will nothing but the difference of enthalpy change. So this if you are deriving this equation, then you will get the remaining 1 mark. So in this way you will get 4 marks if you are covering all these points. In this way, the MSBTE paper, that is winter 18, it was carrying about 10 marks contributed by this first chapter itself. So this first chapter is very much important from exam point of view. Along with this theoretical part, you should also know that there will be no any numericals asked from this chapter. So the total weightage will be based only on theoretical questions, and most of this chapter is just having the statements and definitions. So I hope that you have understood the first chapter. We have also covered all the questions from this first chapter which were asked in the MSBT paper. If you still have any kind of problem related with the questions from in this MSBT paper or any theoretical point from this chapter, then you can contact me. So with today's lecture, I conclude the end of the first chapter. So from the next lecture, we will be starting with a new chapter, that is ideal gas and ideal gas process. So thank you very much.